Alright, so apparently the video didn't show the last two examples. It just cut off, and I was kind of sad because I had a lot of work written in them. But anyway, let's redo them. This example, picking up where we left off, it says find the zeros, so the x-intercepts, of this equation given that 3 minus 2y is a 0. So since 3 minus 2y is a 0, we automatically know what has to be the other 0 because of on the previous page, the conjugate pairs theorem. If a plus bi is a 0, a minus bi is a 0. And for the questions we're doing in this class, it's always going to work out like that. So is a 0. Now, looking at the equation, we notice that it's degree 3. And degree 3 means there's 3 x-intercepts, 3 solutions. Not x-intercepts, but 3 zeros. Well, I already got 2 of them right here. So I just got to find the missing one. All right, there's different ways to go about this. The way our textbook chooses to do it is if I know these are zeros, then automatically I know 2 factors. So I know that f of x is equal to, notice my leading coefficient is 1. There's a 1 in front of there. And then the other one is 3 are x minus x minus and then this last one that we're going to try to figure out. Okay, so the zeros they gave us, this is 3 minus 2i, 3 plus 2i. Okay, I'm going to put those in parentheses. And so we get f of x is equal to, I don't have to say 1 times, I can just ignore the 1. So x minus 3 plus 2i, x minus 3 minus 2i, and then we have this missing one that we want to figure out. I know there's only 3 of them because there's 3 zeros. And so all I'm going to do is I'm just going to do synthetic division with each of these. Synthetic division is dividing. Okay? Since these are zeros, I'm guaranteed to get 0 as an answer whenever I do this. So the first one is 3 minus 2i, 3 plus 2i. So 3 minus 2i is the first one I'm doing. Let me erase this. And so we have 3 minus 2i, and the coefficients are 1, negative 8, 25, negative 6. So 1, negative 8, 25, negative 26. Okay, so when I do the synthetic division, I already know that I'm going to get 0 at the end. If you don't, it means that you made a mistake or that I lied to you when I told you it was a 0. So, so bring down the 1. 1 times 3 minus 2i. And now when you're adding and subtracting imaginary or complex numbers, let me give myself some more room. Let me shrink things. Okay, so let me move some stuff around a little more. Fun times. Okay. So, sorry. We have 3 minus 2i. So you can think of this negative 8 as negative 8 plus 0i. I don't like my choice of red there. Let me do it in blue. And so this is 3 minus 2i. And all you got to do is just add up like terms. So negative 8 plus 3 is negative 5. I chose blue. I keep on getting the wrong color. No. Okay, so that's negative 5 minus 2i. And now we're going to multiply negative 5 minus 2i times 3 minus 2i. And you're going to do the multiplication kind of just like we were doing up here. It's just foiling. So 3 minus 2i, negative 5 minus 2i. What am I doing? And so when you FOIL it out, first times first is negative 15. First, our outer, first times last is minus 6i. Inner, negative 2i times negative 5 is positive 10i. And then last times last is plus 4i squared. But we know that I squared is negative 1. So we're going to change that in the next line. So negative 15, negative 6i plus 10i is plus 4i. And then that's negative 1, so this just becomes minus 4. So this number is negative 1. And then negative 15 minus 4 is negative 19 plus 4i. And so that's what's going to go over here. Again, this is really plus 0i. Add them up. 25 minus 19 is 6 plus 4i. I keep on getting my colors all messed up. So 6 plus 4i. And then we got to multiply again. So this requires you knowing how to FOIL quite a bit. 6 plus 4i times 3 minus 2i. Let me get this work and shrink it. All right, so I'm going to choose a different color. So 6 plus 4i times 3 minus 2i. And outer, 6 times 3 is 18. Sorry, first times first is 18. Outer is 6 times negative 2 minus 12i. Inner plus 12i. And then last times last is negative 8i squared. Okay, one thing to notice is that these imaginary numbers cancel out. And you're left with 18. Remember that I is really negative 1. So that's negative 8 times negative 1 is plus 8. And 18 plus 8 is 26. And notice life makes sense. Negative 26 plus 26 is 0. All right, so now that we got that done, all you got to do is this becomes our answer now, because when you did do synthetic division, your quotient is kind of like the new problem. And now I'm going to do the other 0. The other 0 was 3 plus 2i. So if I do 3 plus 2i and do it again, the reason why I'm not using the quadratic formula is no one wants to do the quadratic formula with that. Please don't. It's no. If you know the other imaginary 0, go ahead and do another synthetic division. This one will be a lot shorter because there's only 3 terms. So I bring down the 1. 1 times 3 plus 2i is again 3 plus 2i. Add like terms, and notice life's happy. Negative 5 plus 3 is negative 2. And right away, negative 2i plus 2i cancel out. So that's just really just a negative 2. You don't have to write plus 0i. And then negative 2 times 3 plus 2i is negative 6 minus 4i. And lo and behold, those cancel out to be 0 again. Because I told you they were x-intercepts. So if you do synthetic division with it, you get 0. Now look what our quotient becomes. So we've successfully divided by this first factor, we divide it by the second factor, and all that's left if you divide by these two, and let me move my, so I divided by this one, then I divided by this one, and if those two are gone, all that's left is the missing factor. And so the missing factor ends up being x minus 2. Which implies that if this equals 0, that x equals 2 is the missing x-intercept. So your x-intercepts are x equals 2, x equals 3 plus 2i, and x equals 3 minus 2i. All right. They didn't tell us to write it out in terms of linear factors, but we can. Remember that my problem was f of x equals, and I already had it written over here, x minus 3 plus 2i, x minus 3 minus 2i, and like we said, the missing factor was x minus 2. And there you go, you factored it. The reason why there's no number in front of there is because the leading coefficient is 1. Okay? So hopefully that made a little bit of sense. The very last two problems on your homework are going to be something like this. You do synthetic division with the imaginary zeros they gave you. Okay, now if you're foiling, if you have to do the box to foil, go for it. I mean, right now you're just trying to make it through this class, right? So for foiling, if you have to do the box, go for it. You're going to get the same answer I do. Okay, last one. So this last one's a really, really long problem, but it's trying to show you the whole point for this guess and check process. Notice that this is degree 5. So that means we're going to have 5 x-intercepts, or 5 zeros to find. And again, remember, a 0 is a 5 solutions to the equation equals 0. So I don't know what they are yet, but I know that since it's degree 5, if I set this equal to 0, I'm going to have 5 answers. So first we're going to create our list of possible rational zeros. And what you do for there is you take the very last number, you take the very first number, and it's going to be the last number goes on top. Factors of negative 18 divided by factors of 4. So negative 18, it's plus or minus 1. 1 fits into 18, 2 fits into 18, 3 fits into 18, 6 fits into 18, and 9 fits into 18, and then finally 18 itself. For 4, 1 fits into 4, 2 fits into 4, 4 fits into 4. So again, what you're doing is you have your 3 denominators, and you just want to pair each numerator with each of those 3 denominators. And if it repeats, you don't repeat the number. So 1 over 1 is 1. 1 over 2, 1/2. 1 over 4, 1/4. Okay, then I'm done with that one. I move on to the next one. 2 over 1 is 2. 2 over 2 is 1. I already have it. 2 over 4 is 1/2. I already have it. Okay, so move on to the next one. Oop, I erased my 2. Now we're doing 3. So 3 over 1, I'll go down here. 3 over 2 is 3/2. 3 over 4 is 3/4. Done with that one. Move on to the 6. 6 over 1 is 6. 6 over 2 is 3. I already got it. 6 over 4 is 3/2. I already got it. Move on to the 9. 9 over 1 is 9. 9 over 2, 9 over 4. Done with the 9. Move on to the 18. 18 over 1 is 18. 18 over 2 is 9. I already have it. 18 over 4 is 9 halves. I already have it. So here are all my possible solutions. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, but plus or minus for both. So there's 24 possible fraction solutions. Now, what we mean by that is if the answer is a fraction, and remember whole numbers like 1, 2, and 3 are fractions. If a solution is a fraction, it must be in that list. Right? And usually for this class, all of them but 2 are going to be in that list. The last 2, they might be in there, but if they're not, that means that you have to use the quadratic formula to figure out the last 2 answers. All right. Anyway, so the next part comes the guess and check. So I'm going to actually start up here. So we're going to do guess and check. I can't spell guess. And so looking at that, really you have 24 possibilities. You pick one, and remember you're hoping to get 0 when you're done with when you do synthetic division with it. So I'm just going to, again, I'm kind of boring. I'm just going to choose one. So if I do synthetic division with this, didn't really give myself any room, did I? Nope. Gilbert struggles with room space. Okay. So I have 1. I open up my bracket, go all the way across. So I try to be tricky here. I have 4x to the 5th. Notice that 0x to the 4th. You have to have the placeholder for every power of x. And then 3, 2, 1, nothing. Okay, so that's the only placeholder. So it's going to be 4, 0, negative 11, 13, 12, and then negative 18. It's hard to write tiny. So we work it out. 4 times 1 is 4. 0 plus 4 is 4. 4 times 1 is 4. Negative 11 plus 4, that's negative 7. Negative 7 times 1 is negative 7. 13 minus 3 is, my brain is dead right now, 6. 6 times 1 is 6. 12 plus 6 is 18. 18 times 1 is 18. Check that out. That's why I wanted to kind of shimmy it in here, so you could see everything on the same screen. But notice that we got 0 at the end. That is something that we want to happen. That's good. This means that this is my new problem. And it means that x equals 1 is a 0, because I did synthetic division with it, and the answer is 0. Now, once you find one, never, ever, 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 ever go back to the original problem. What you're going to do is this becomes your new problem. The whole point of this process is that the polynomial gets smaller. We went from a degree 5, and what we did is we factored out the x minus 1. Remember, if it's x equals 1 is a 0, as a factor, you have x minus 1. So what we did is we factored the x minus 1 out, and what's left is this. So the multiplicity of 1 could be higher, meaning it could happen more than once. So because of that, we're going to try 1 again, but this time with the new answer. This one was a yes, because it worked. So we try 1 again. And now my new problem is 4, 4, negative 7, 6, 18. And when we work it out, 4 times 1 is 4, 4 plus 4 is 8, 8, 1, 1, 7, 7. 18 plus 7 is 25. Notice that this is not 0. So since it's not 0, that means now I can cross off the 1, meaning that this 1 only happened once. It only worked once. So the multiplicity of 0 is 1. Okay? The behavior at 0, since the multiplicity is 1, it means that it crosses like a line. It crosses straight through. Which means that it doesn't flatten. When I say flatten again, I'm using this from last semester, so that was what I did last semester. But when I say flatten is, does it look like an x cubed? Okay, so there's that 0. Now I'm going to see if I can copy paste this, because I want to show you something. Control C, Control V, move that over here. So now I got all the room. Okay. So even though it didn't work, notice that all the numbers here are positive. That means that now that we've made the problem smaller, 1 becomes my upper bound. So that means that there's going to be no solutions larger than 1. Okay? Or at least for this new polynomial, there's no solutions larger than 1. So look at all the answers that I have that are larger than 1. I'm going to get rid of 2. So that means plus 2 gets eliminated, plus 3 gets eliminated, plus 3 halves gets eliminated, plus 6, plus 9, plus 9 halves, plus 9 fourths, plus 18. Okay, so if you notice that everything's positive, sometimes you can eliminate a lot of answers. There's no point in trying them. They're not going to work. All right, so now let's keep on chugging. You're still using your new problem, but now I'm going to try negative 1 now. So negative 1, I have 4, 4, negative 7, 6, 18. Remember, we're using my new problem. I pointed to the wrong thing. The new problem was the last thing we got when it worked. So 4, 4, negative 7, 6, 18. So 4, 4, negative 7, 6, 18. And we work through it. So 4 times 1 is negative 4, 0, 0, negative 7, positive 7, 13, negative 13, and 5. Okay, so that doesn't work. And it's not all positive on the bottom, and it doesn't alternate. So that's the only number we can eliminate. Every time I eliminate one, I'm going to make it small so I can have space. Okay, so we're finally done with the ones. Now let's go ahead and try I'll do plus and minus a half. So let's try a half. I have 4, 4, negative 7, 6, 18. And then I can do synthetic division with it. 4 times a half is 2, 6. 6 times a half is 3. Negative 7 plus 3 is negative 4. Negative 4 times a half is negative 2. 6 minus 2 is 4. 4 times a half is 2. 20. Nope, that's not it. Let's move on to negative half. And that's all you're doing, is you're just guessing until you find one that works. So I have 4, 4, negative 7, 6, 18. So 4 times negative a half is negative 2. 2 times negative a half is negative 1. Negative 8 times negative half is positive 4. 10 times negative half is negative 5, and that gives me 13. So nope, not that one. Now to save time, I'm gonna give you the right answer, but you would keep on guessing until you finally got one that worked. So it turns out that out of all of these, there's only one of them that works, and it's gonna, or aside from the one that we did in the very beginning. So the only other one that works is negative 3 halves. So I'm gonna do negative 3 halves, and let's work it out. So let's say you keep trying and trying and trying, and eventually you stumble upon negative 3 halves. So it's 4, 4, negative 7, 6, 18. So 4. Now when you're multiplying, you can use your calculator to figure out what the fraction is when you multiply them together. But if you're doing it in your head, you just multiply to the top number and divide by the bottom. So 4 times 3 is 12. 12 divided by 2 is 6. So that's going to be negative 6. Negative 2 times negative 3 is 6. Over 2 is 3. Okay, negative 4 times negative 3 is 12. Over 2 is 6. This is 12. 12 times 3 is negative 36. Over 2 is negative 18. And so you get it, that works. Which means that this becomes your new problem. Okay? Other things that means is, since that worked, I know that x equals negative 3 halves has to be an answer. Which means that x minus 3 halves, sorry, x plus 3 halves has to be a factor. Right? But then we have to ask ourselves the question of how many times does it happen? Does it happen only once, or does the factor happen more than that? So now that we have our new problem, what you do is you keep going. Just because it works doesn't mean you cross it off the list. So negative 3 halves, again. And now I'm using the new problem, 4, negative 2, negative 4, 12. And we repeat it. 4, I know that's going to be negative 6, negative 8. 8 times 3 is 24, over 2 is 12. Okay, 12 minus 4 is negative 8. And then again, we work this out, and that becomes, wait, did I do something wrong? 4, it should work out again. 12 over 2 is negative 6, negative 8. Oh, oh god. 8. And then 8 times 3 is 24 over 2, so negative 12. And so notice that this happens again, which we have another new problem. Now, since it's the same number, I don't write it twice. I just say that the multiplicity is 2. I'm kind of jumping the gun there because you say, well, what, couldn't it happen more than that? Actually, let's just to prove it. So I already know what the answer is, so it's kind of easy to assume things. But in keeping with what we were doing, yeah, you wouldn't know if it happened more than that. You're like, oh, look, does it work yet again? All right, so 4, that gives me -6. Um, -8 minus 6 is -14. 14 times, I have no idea. 14, 14 times, 14 over 2 is 7. 7 times 3 is 21. Okay, so positive 21. And notice that you get 29 as your answer. That's not 0, so now it doesn't work. So because of that, it only worked twice, so the multiplicity has to be 2. Since the multiplicity is 2, we know that it bounces or touches like a parabola. And does it flatten? Does it look like x cubed? No. All right. So it turns out that if you kept on guessing and checking, you never find the last number because the last two numbers because the last two numbers are not in the list. Once you get down to 3, notice that that's a quadratic. If it's a quadratic, so I'm moving up here. If it's a quadratic, I have 4x squared minus 8x plus 8 equals 0. And I can actually solve this using the quadratic formula. Okay, because the last two answers are, in this case, they're going to be imaginary. So 4, I factor the 4 out. And then if I'm doing the quadratic formula, the numbers are relatively small, so hopefully that's not too bad. We get x is equal to negative b. Let me do a different color. I'm just gonna, So x is equal to negative b, 2, plus or minus. Cat's having fun with a scratching post. Uh-oh. Okay. So negative b is positive 2 plus or minus the square root of b squared, so that's 4, minus 4 times a times c is negative 2, and then the entire thing divided by 2a, which is 2. So x is equal to 2 plus or minus 4 minus 4a times c. Did I mess up? A times c is negative 2 minus 4. Wait, hold on. I need to catch something that I did. Let me pause the video. Where did it go? Found it. Yeah, so again, it's little mistakes that get you. And I knew I was wrong because I've done this problem a couple times already. That was actually a positive 2. Which means that that's a times c is positive 2. So that's 4 minus 8. Okay? So remember order of operations when you're subtracting. 4 minus 8. So 4 minus 8 is negative 4. And then the square root of negative 4 is going to be 2i. All right, so to finish it off, we have 2 plus or minus 2i over 2. And you divide each one by 2. You can't pick and choose what to divide by. You have to divide by everything. And so your final answer ends up becoming 1 plus I. plus or minus I. And those are the last two solutions. Zooming back out. All right, so up here, the other two zeros would be x equals 1 plus I, x equals 1 minus I. And the factors for those are just x minus those numbers. So we have x minus 1 plus I, x minus 1 minus I. Oh, almost forgot. Since the negative 3 halves happen twice, the factor would be squared because there's two of them. All right. Anyway, so it's okay. Sometimes you have really good luck when you're guessing checking, and sometimes you'll just get the answers right away. Other times, it could take a while. Or sometimes you just have really bad luck and you don't find the answers until the very end. I'm trying to reorganize my stuff here. So that way you'll see that it's in order. Don't mind me. Because I also wanted to make this a little bit bigger. Not that part. I wanted to make the quadratic formula part. Because it was all scrunched into that corner. Okay. I'll work on it later. Anyway, so the final part is write it in terms of linear factors. Well, since you know all the x-intercepts, I already have the factors on the left side. So it's going to be f of x is equal to my leading coefficient. The leading coefficient was 4. And then I just write down all the factors. X minus 1, x plus 3 halves squared. Then if I distribute that negative, x minus 1 minus I, x minus 1 plus I. So there you go. You started out with this really, really nasty equation, degree 5, but because we were able to find the x-intercepts, we were able to factor it. And you have the complete factorization. All right. Anyway, sorry that this chopped off. I'll post it underneath the video on Canvas. And again, let me know if you have any questions. There's not going to be any problems this hard on your homework or on the test, but I just like doing a degree 5 to show you. It kind of gives you more idea on the process of how you do these problems. Oh, let me fill this in. Multiplicity 1, they each happen once. And this is a trick question. You can't see imaginary answers, so they don't have any behavior. It's just all right. So let me close this off and hopefully it saves this time.